Cool. Well, hi, everybody. My name is Cole Clark. I'm joined today by two of my teammates, Kovit, Nisar, and Michael Santos. And for a brief little background on us, we're part of a team within IBM Research called Apps at Research. And so our team manages and develops a suite of web applications and services that are used by other researchers within IBM. And so some of these applications and services that we manage have come from a variety of different sources. Some of the apps we've inherited from other teams around IBM, and some of them we've created just from the ground up ourselves out of necessity. But this can be both fun and frustrating at the same time. It's always fun to learn new things, to learn different technologies, learn different languages, especially when you're given an application and you kind of have to figure it out on the fly. But at the same time, it's often a frustrating process if you're under time crunches to figure out how the runtime environments work, and or you can't figure something out in one language that you know how to do in another. So as developers, we've had to be really flexible and kind of just go with the flow here. And each one of us, Michael, Kovit, and myself, have dealt with each of the languages that we're going to talk about today. So we're just going to kind of go through an overview of creating an API in 3 different languages with 3 different runtime environments, and discuss a little bit about the comparisons between these technologies and why you may use one over the other. But really the goal of the presentation is just to provide a high-level overview of advantages and disadvantages, but a lot of what it comes down to at the end of the day is just your specific use case, your business requirements, and also a little bit of personal preference, of course. So yeah, we'll speak a little bit on our experiences. We're going to have some slides and some demos with each one, but we're going to go over Python with a Flask runtime environment. Kovit's going to go over Node and TypeScript, and then Michael's going to talk about GoLang. So yeah, our presentation, are you a polyglot? And obviously polyglot is, being able to speak different languages, but in this case, we're talking about programming languages. So before we start with talking about a specific language, today we're going to be talking mostly about backend services, as that's what we deal most with. And so when you think about backend services, we think about a few things. First of all, performance. Can you handle multiple requests, and are you able to scale your environment as you get more users? Package management. So what libraries are included? Can you extend your code easily, or do you have to make things yourself from scratch? And also being able to control the versions and vulnerabilities within those packages. And then just ease of use. So is there a lot of documentation? Is there a community around the language that will make it easier to kind of figure things out on the fly? And also, if a new developer comes on and reads through your code base, will it be easy for them to pick it up, or will it be hard? So all of these things are kind of just things we keep in mind when creating services. And so just to jump right into kind of the first language and framework that we're going to talk about, Python and Flask. So we have one of our applications running in Python and Flask. And so if you don't know, Python is a very widely used language. It is used a lot for backend services. It is dynamically typed, object-oriented, and an interpreted language. So it's not compiled beforehand. Types will be figured out kind of on the fly by the program itself, by the interpreter. And then Python uses something called pip, which is a package manager. So pip allows you to install tons of different libraries, and it's probably one of the most comprehensive package managers out there. There's so many libraries, it's even hard to choose which one you need at some points. But Python's great because it's really readable. It uses less lines of code than a lot of other languages. But even though it's readable and very easy, user-friendly, in general, it runs a little bit slower than compiled code, just because it is interpreted. But yeah, we'll talk about that in a little bit. And then, so when we're talking about creating an API, Flask is a library that is available through the pip package manager. in Python, and it's a micro web framework for Python that implements the WSGI protocol, which again we'll talk a little bit about that, but it includes a lot of the tools for routing and serving web requests. So you're able to use get, post, put, delete requests in your APIs. It's great because it's very lightweight, it's easy to extend, and it kind of allows you to pick other tools that you want to use with it. So for example, we use SQL Alchemy, which is another library that's an ORM, which communicates with our database. But if you want to use something other than SQL Alchemy or other packages with it, you're not tied down to using anything specific with Flask. But one of the downsides to Flask is that it's synchronous. There has been talk of creating a Flask asynchronous version, which I think is coming. But at the moment, Flask doesn't recommend that you use Flask in production. It's just a development server. So for production, they recommend using something called a UWSGI server, which is asynchronous, which means it can kind of handle more requests at once than a typical Flask application. So with that, I'm going to jump into a small little application that we wrote. So Michael Kovit and I will kind of all go through the same API that we wrote in these different languages. So the API itself might be a little repetitive, but it'll just give you an idea of what the language looks like, how to set things up, maybe how easy or how hard is it. And yeah, we'll go from there. So with Python and its package management, typically the best practice is to use something called the requirements.txt file. So once you have Python set up on your machine, you'll also get pip. And within your project, you'll start by just installing the package that you need. So for us, we're just going to use Flask, and we're going to use something called PyUWSGI. The other nice thing about Python is that it does come with, it recommends that you use something called a virtual environment, which is just good for developers because it allows you to kind of segregate. If you have multiple projects, a virtual environment will just segregate those projects so that when you're installing dependencies, you're installing them in this specific then for your project, and they don't translate over to other projects. But yeah, so we're just going to start by installing our requirements.txt, and you'll see I already have those installed here. And some of these other packages are dependencies that are needed for Flask and PyUWSGI. So once we have Python set up, we have the requirements, we've installed some of our libraries, we're pretty much ready to start coding. And in Python, you can see it's really short, not a lot of code in here, but this is just an app.py file, which will run our main application. And so from here, we're just going to import the Flask library and create an object that Flask is going to be, we're going to be able to interact with Flask through that object. And so the Flask object, all you have to do is tell it where your main module is going to be running from. So in this case, our main module is this file, because when we run this file, we're going to run the app.run command, and it will start up our Flask development server. And so to begin, we just, Flask allows you to use these decorator functions around your main functions that will handle your web requests. So in this case, we're starting out with just a simple route at our root that will return hello world from our application. So again, very simple. And we're already kind of up and running with Flask. So once you installed your Flask library, you'll also get the Flask CLI. And to run this, we just run Flask run. And you'll see you get this warning about this is a development server, don't use it in production, use WSGI instead. But it's great for development because it's really easy. And so when I go to our local host in 5000, which is the port that it's using, we'll see we get our Hello World application up here. The other nice thing about Flask is that it comes with a lot of other functions and objects that you can use. So one of the things that we use a lot is called blueprints, and blueprints act very similar to the Flask app, but in this case, it's just another way to kind of segment your API. So for this example, we just set up a small little kind of database, I guess you could call it, of just some test data. It's just in JSON. And we've got this user's blueprint where we create a blueprint object and we name that object, and then we tell it which module that object is in, which is our current file. And from there, it works very similar to the Flask app where you can create routes. In this case, you can say what method you're using. So if it's get, post, put, and the route that you're going to be using. So we just set up a small little application that has, we have a route that will get all of our users, a route that will get users by a specific ID, a route that will post, so it'll create a new user, and then a route that will put or update a new user. The other nice thing about Flask with these additional functions and libraries is it has something called JSONify, which JSONify just serializes objects or dictionaries, lists, so that you don't have to worry about serializing things and sending them back in JSON format. So it does all of that for you. And then request, this is a way to interact with either the body or the request parameters that come in. So if you have a post request like we do here, you can just ask for the body of the request with get JSON, and you get the whole object. It's really easy to use, and as you can see, we've written maybe 50, 60 lines of code. We've got 5 or 6 routes up. And yeah, so if you go into Postman and and lastly, after you create your blueprint, all you need to do with Flask is just register it to your application. So once we created the app, we also registered our blueprint. And with the blueprint, you can just easily create prefixes. So in this case, our everything in the user's blueprint is going to be prefixed with API version 1. And so, yeah, if we go in here, we can get all of our users. We can get a user by a specific ID. We can create a new user, which will be me. You can see that it'll show up in the list here. And then if we want to update me to only have first name and a new email, we can do that as well. So that's pretty much it for Flask. Once we have our Flask apps set up, the next thing that we do usually is we Dockerize everything, just because it's easier for our teammates to run things in Docker, and you don't have to worry about figuring out your whole environment. And Dockerizing it is pretty simple. It's everything that we kind of went through here, where we just install Python from an image, we install pip, we copy in our requirements file, we install all of our requirements, and then we copy in all the files we need, and we run it at that Flask run command. The other thing that I mentioned about uWSGI, so since Flask is synchronous, they recommend using a WSGI server. So a WSGI server just sits on top of your Flask application and interacts with your Flask application. But a uWSGI server is asynchronous, so it can handle a lot of requests at once. For us, we develop typically in Flask, and then when we deploy to any of our environments, we have we have a test environment and a production environment. We use uWSGI, so it does add a little bit of complication just because we are kind of managing 2 things at once. They do work together, and uWSGI is simple to set up. You just have to create an INI file and tell it where your Flask app sits at and what port. But uWSGI comes with tons of configurations. It's so many that I don't even know what most of them do. So it can be a little bit overwhelming. But overall, yeah, this is kind of how we set up our projects in Flask and Python. And so I'll hand it over to Kovit to talk about Node now.
Can you guys hear me? Okay, thanks, Cole. So, I'm going to talk about, good morning, everyone. I'm going to talk about Node.js, Express, and TypeScript framework. Now, similar to like we have Python and Flask in order to create web server-side web application framework, we have tons of option to do that, and Node.js, Express, and TypeScript is one other option to create server-side backend web application. Now I'm going to talk a little bit about each of these frameworks and Node.js language in particular, and then show a quick demo. And at the end, we'll talk about why do we use Node.js along with Express framework and TypeScript language for some of our web applications. So let's get started. So what is Node.js? Node.js is an open source cross-platform Java runtime environment. Basically, you can create server-side web applications using Node.js. Now, it's important to understand how Node.js actually work. So there are three main components for that is through which the JavaScript runtime environment is implemented, and those are Google Chrome V8 engine that compiles your JavaScript code for Node.js. You have an event loop that handles incoming requests and tasks. And then you have libuv, which actually handles the asynchronous IO non-blocking part. Now, it's the event loop and libuv that makes Node.js an asynchronous non-blocking IO. So the way event loop works is for any incoming request, it's the event handler that handles those requests and puts events into the event loop's main thread. Now, event loop itself is single threaded. So event loop processes those events one by one, and any event that requires an IO operation, it puts those events into a worker thread, which then kernel. So basically, it offloads the work to the kernel. The kernel then processes those IO operations, which could be a network call, a file system, a database call, a call to Elasticsearch, or any other microservices. Once the kernel is done with processing those IO operations, it calls the associated callback, which is then placed back to the main thread, and event loop will eventually process it. Now, since event loop is a single thread, you need to understand that if you have a task which requires a heavy CPU utilization, then that task will probably stall all other events. So basically, Node.js is good for small data intensive and data streaming applications. But if you have applications that require heavy CPU utilization, then probably Node.js is not a good solution unless you scale it horizontally. So like Python, Node.js also has a huge ecosystem. And one of the web application framework that we use to create RESTful endpoints is Express. And two major advantage of Express that we probably like is one is it's how easy it is to create a routing algorithm, meaning create RESTful endpoints for your application. And the second thing is the use of middleware. The middleware allows you to process any incoming request. For example, we have an authentication middleware that will process each and every request that arrives and checks if the user is authenticated. If not, it will redirect it to the login page or the SSO. Now, Node.js also has a lot of compiled to JS languages, which adds some synthetical advantage on top of Node.js, and one such language is TypeScript. So TypeScript is nothing but JavaScript with static typing. Now, the reason we use TypeScript is because we have developers from background from Go and Java backgrounds, which are static languages. TypeScript introduces types, but along with types, you can provide structure to your code by using classes, generics, and interfaces. And TypeScript provides you great integration with your editor, so you can do an autocomplete, and also helps you to catch errors early in the stage during compile time instead of runtime. Now with that, we'll go to the demo. Okay, so it's now like Cole showed you those APIs. I have a similar implementation that I want to demo. But in order to get started with Node.js, you need to create a package.json file. Now, this file either you can create directly in your editor, or you can do npm init -yes to create this packet.json file. Now, packet.json is nothing but contains much data about your project. You have your project name, version, licensing, and most important, what are dependencies your project require. Now, since we are using TypeScript, we need to install TypeScript packages. Now, you can do that through NPM, which is Node Package Manager, uh, which allows you to actually install, manage, or install your dependencies. So the way you do it is NPM install TypeScript. And you need to install Express, since that's the framework that we're going to use. Now, Express and Node basically are JavaScript languages, are implemented in JavaScript. So you need to download or install the type definition for Express and Node, so that you can do that using types Express and types Node. Once you run this, it will install all these dependencies in your Node module folder. Okay, now, as I said that Node.js only understands JavaScript, you need to compile your TypeScript files. And so you need to have a tsconfig file that actually contains TypeScript compiler configuration. Now, in order to create a tsconfig file, you can do npx tsc -init, which would create this tsconfig file for you, and you can change the settings as required. Now, once you have your code, you need to convert your TypeScript code into a JavaScript code, and so TypeScript comes with a compiler which you can use using npx tsc, and it will compile all your code into JavaScript code and put it into an output folder, probably whatever you configure in a compiler configuration. For example, I have this amp.ts file, and we'll go through this. So similar model, similar implementation to what Cole showed. We have a user module. Now, TypeScript allows you to define classes and interfaces. So probably you will create a user class to create user objects, and then you will have just a second. You will have a user service to interact with the database. Now, important thing is I have defined the functions as async, because Node.js allows you to create asynchronous functions for your IO calls, database, and so. And you need, when you have an async function, you need to provide a callback too. So let's look into app.js and see how easy it is to create your RESTful endpoints using Express. Now, the first thing is you will import Express here, you will instantiate Express. And once you instantiate Express, you just, in order to create a RESTful endpoints, you have to define the HTTP method, which will be get, post, put, delete. You need to define the path, and you need to define the request handler. So any request, any HTTP GET request to this path will be handled by this particular handler. So similar to what Cole did, I have an HTTP GET RESTful endpoints for getting all the users. I'm getting all the users from database. Now I'm doing now this is an async function. So I'm waiting for the basically it's a non-blocking async call. And once the database call happens, this particular callback is called in order to process all the users. Similarly, I have post calls and put calls for creating new users and updating new users. At the very end, you can create a server and by calling app.listen and then and give it the port. Now, as Cole said, since we Dockerize all our applications and deploy it on OpenShift, we have a Docker containers for that. So in order to, I have a similar Docker file, which I will run using Docker Compose build to build my project. Since it's a TypeScript project, I need to build and convert transpile all the TypeScript code into JavaScript. Now, what it's doing is npm run install all the packages, which goes into node modules, and then it runs an npm run build, which basically it's running npx tsc, compiling or transpiling your TypeScript code into JavaScript and putting into this folder. This app.ts, when transpiled back into JavaScript, TypeScript converts back into JavaScript files. You can see it here. Now, in order to run my project, I just use Docker Compose up, and it should start my server by running the node command. And as you can see, it's already hitting the server. And if I say users, it's going to bring all the users for me. Similarly, I can call all other REST endpoints to create users and update users. Now with no, it's important to understand Node.js architecture because the way event loop works and way you can actually run asynchronous non-blocking IO calls for some of our applications, which are data-intensive applications, which requires users to enter a lot of data in a form, and we need to process the data, store the data in database, use file systems to upload and download files, and also probably have other microsystems that are web applications integrate with Node.js is probably a very good solution for all this, for this particular problem, so such problems. And so we use Node.js for all our data-intensive data streaming requirements. The other thing is that since it's JavaScript, most of our developers are actually full stack developers. They know JavaScript because they use it in front end, and so it's easy for them to create backend applications because Node.js is ultimately a JavaScript language. The other thing is the Node.js ecosystem. Now, like Python, you have Node.js also has a good ecosystem, and so you can find packages for almost everything. And the last thing is scalability. Now, as I said, we Dockerize our programs and deploy it on OpenShift. We can scale Node.js web applications horizontally by adding more pods or more servers, and we can scale it vertically too, either using PM2 or cluster library. So that's how we use Node.js. For some of our newer applications, we are using Node.js along with GraphQL and type ORM, and Aditya is going to cover that particular session later in the afternoon in this conference. With that, I'll hand over to Michael, who's going to explain GoLang and how we use GoLang and where we use GoLang. With that, I'll hand over to you, Michael.
Thank you. Let me just share my screen here. Can you see my screen?
Yes.
Thank you. Okay, so thank you, Cole and Kovit. So I'm going to talk about a little bit about GoLang, basically yet another language that we use at work. So a quick background on GoLang. As the word kind of implies, it came out of Google. And the reason for it was, I think around back in 2007, Google was running a lot of servers in C++ and in Java. And even if those languages are very effective for writing server code, it's not very easy. The development is slow and sometimes not very efficient. Effective, but not very efficient. So a couple of engineers at Google started tinkering around, and what they came out with was Go. So Go does some things very well. And I think the reason why it does that is because it was built and designed with a specific task in mind, which was to allow teams to be fast. It was so that the productivity could increase, something that would allow for easy maintainable code, something that could scale very well. So Go, by comparison with Python and Node.js, is a lot simpler. One example, for example, that I always think is interesting is usually languages have all different types of loops. You'll have a for loop, you'll have a while loop, some even have do whiles, and Go has a for loop. You can mimic a while loop. There's a way how to do it, but there's only one loop. There's the for loop. So it's simple in that sense, but then it also has a very rich environment where, and I'll show that in a second when I go to the terminal and I'll do the code. But Cole, for example, said that for Python, for managing libraries, you have pip. Kovit talked about npm. There's even yarn that you can use. So you have all these other package managers. Go has its own. You do go get, and it'll get whatever you need. So as a development tool, Go has everything that you need to test, run, builds, get all your package in one place. And that is, when you think about it from a team trying to be fast and productive, it's great. Of course, this has some downsides where, for example, Go is not I wouldn't call it a research language, for example, because it's very simple in what it does, and that's what it's focused on for large systems and large backends. It's not a research language. I mean, Python, by comparison, for example, is great for anything machine learning, and Go isn't. That's just how it is, right? So Go as a language, though, is it's a compiled language. It is somewhat object-oriented because it doesn't have inheritance. It is statically and strongly typed, and it has a garbage collector. So it's very simple, and it does what it does really well. As a comparison, so I think, Cole, you mentioned you were using Flask. Kovit, you're using Express. The framework that I'm going to be using is Gingonic. So I would also say that Go doesn't have such of a rich environment of packages. So usually you have to make your own, but usually when there is a package that solves something or some type of framework, it will be good. And like Gingonic, for example, is a high performance HTTP web framework, which is just great. It really reduces a lot of the boilerplate when you're building an API. That's what we're going to be using. Of course, you could use the built-in HTTP package that Go comes with, which Gingonic, of course, is built on. But you're just going to be building a lot of the stuff on your own. And Gin, even though pretty lightweight, has very, very good performance. It leverages Go's concurrency. I think I forgot to mention that. That is also one of the very advantages that Go has over other languages is concurrency. It's built in, very easy to use. Go is very similar to when writing and even when interacting with it to C. Go has structures, and if anyone here has ever done anything in C, you'll know how much of a pain it was to get anything running asynchronously. And Go does that really well with something called Go routines, and then channels. Channels is basically how you allow for data to be passed from one Go routine to another. So I think that's enough from a quick introduction to what Go is and what it isn't. Let me just quickly, okay, so going over here to the code, I'm going to be doing the exact same thing that Cole and Kovit did. So we have two files here. Just like Cole, have a structure over here that defines a user. The user will have an ID, a name, and an email. Have a quick array over here with 2 users already in it. I'm going to call this our database. And then I have my main file. Again, very similar to C. We have a function main. This is basically entry points of our code. There's also a function init, which will run before our main. And then our imports up top. So we are, like I said, using Gingonic, which is an HTTP framework. This does something very, very similar to what Flask does in Express. You basically define a router. This router then will have specific endpoints. We have a root. We have a get at users. We have a get user by ID. We have a post to create a new user, and we have a put to update an existing user. So not many lines of code here also, and we're basically going to have something up and running, very simple. So Go, another interesting thing about Go is because it's not a very old language, because like I said, it's came around 2007, it has been evolving. So like when I started using Go, I remember that the way to use it on your system was very rigid. You had to have a well-defined structure of where your code had to live, or Go would just not like it. And everyone just accepted that was the best way to do it. It wasn't. It really wasn't. It was a pain. You had to make sure that all your packages were in one place and your source code was in another. So with everything, Go improved on that. And today we have something called Go modules. So Similar to package.json for Node.js or the requirements.txt for pip in Python, we have what Go calls modules. So the first thing you would want to do is init your modules. So let's do a git mod init. This is going to create my little file over here called .mod. This basically is where all the imports are going to be added. And to do that, go mod tidy. We'll basically look at our code, see what needs to be added, and add it in. So you'll see that now we have our file with all the packages, and then a git sum, which basically creates all the relations between these packages and the appropriate hashes for versions. So this is basically the equivalent of managing our packages in Go. And this was very easy, very simple. And before it was a pain. So it's good to see how Go evolves over a couple of years. I even think one of the biggest pain points was Go doesn't allow for method overloading, and until recently, it didn't allow for generics. And generics have just been added in. So like I said, these things were left out because at the time, those who created the language said for simplicity, because they just wanted Go to do one thing and do that well. But as the language evolves and the need for different abilities, it is good that they are adding these things in. So at the end, I'll also show this running with Docker, because we do Docker with everything. But for just to show how Go has everything kind of like built in, without even building your code, you can do a Go run. You have to pass in all the files. In this case, we have two, main and the database, and this will run our code without the need to actually build it. So you can see over here that we have a server listing on port 778. So if I go over here to Postman, and if I do, so if I do over here a get all users, here we go. I can get all my users. Let me create, let me see, this is get by ID. So I have only two. Here we go, get user one. I will add a new user. I'll add myself. Let me see, let's get the new, there we go. I just added myself. And then also just to finish up, I can update. I believe I have my name as Michael Santos, and I'll just shorten it to Michael. Get all the user list again. There we go. So again, very simple API, the exact same thing Kovit presented. But as you saw, I was able to just run this without even having to build anything, right? But Go is a compiled language, meaning that you can actually build, you can actually compile an executable. So let's do that. So if I do Go build thing, here we go. And the output of that was this little dot, this main file, which I can now just run. Here we go. Same exact code running. So for anyone who's ever have to dealt with compiled languages, usually if you want to cross-compile, there are flags that you can, of course, specify. In this case, it's targeting my system, the native system. So I was able to just slash main and run it. But if I would want to port it to some other system, I could, of course, cross-compile it. So, of course, like I said, though, usually what we do is we use Docker for this. So if I do Docker compose build, just quickly do this. There we go. And I can just do Docker compose up. And here we go. Same exact thing. Now I have the exact same server. We can confirm that it is, because the user list will have been shortened, because by default there's only two users. There we go. And it's running in Docker. So this is, like I said, it's very simple. One thing I'd like to point out in regards to Go is structures and something called, I believe, the reflection package. So as you see over here, I have a structure, ID, name, and email, and then I have these little tags for JSON. And what this allows me to do is, when returning the data via the API endpoint, I can specify that it's JSON data, and when reading it on the result endpoint, it will be JSON. So what I'm trying to say here is Go is really good at manipulating and reflecting data to structures. You could do JSON, or you could even do XML, for example. So this allows you to build APIs with a lot of ease in order to manipulate structures. Another really cool thing, so like I said, over here we have, so I just want to say, I talked about how you could just do like a while loop. So you could just do this. There we go. By just doing for, this is the equivalent of a while loop. And immediately you can see that now our IDE is complaining because this code is basically never going to be reached because we just locked our code in a forever loop. And I think that also speaks to, if you're thinking that you have a team of developers and you want everyone to quickly come up to speed, GoLang is really good in the sense that it helps you proof your code with the tools that it provides by formatting, linter, testing. It ends up being like a robust all-in-one package. Of course, the price to pay for that is flexibility. Just like I was saying, you can use GoGet to pull packages, but that is the package manager that you get. If you're working with Node or Python, you can choose your own, I guess. So it's good for what it aims to solve. It doesn't solve everything. I'll go back over here to our presentation to kind of like wrap this up. So we talked about 3 languages, Go, Python, and TypeScript. We have a quick comparison over here. Even yesterday, we were talking with some colleagues, and some of them were like, why would you ever want to have a dynamically typed or a language? I mean, there are advantages and disadvantages to everything. And I think that's what Cole was alluding to in the beginning of the presentation, is a lot of this ends up being, what are you trying to build and what language suits you the most? So for example, when we're building anything that is going to be bombarded on a daily basis, I would probably push for Go. If it doesn't need a UI, all it needs to live in its own little microservice, Go usually is a good thing to go for. If we need a UI for it, Node.js with TypeScript, there's a very big advantage in having your developers basically being familiar with the full stack on the front end and on the back end. And then Python, even just from a research perspective, language is great. If you're doing anything with large data, I mean, it's hard to beat Python, right? Cole, Kovit, you guys want to add anything else in here?
I think for some of our newest microservices and cron jobs, you're using Go because of its ability to do concurrent tasks, as well as easily create microservices. Yeah, but I think for data intensive or data streaming, I would still go for Node.js. And looking at some of the benchmarks with respect to the throughput, Node.js and Go are a good choice over Python. But any computational heavy task, machine learning task, probably I would go for Python or Go.
Yeah, so I think what we're trying to the main goal of this is there is no one good language that does everything. There is definitely different languages for different problems. And I think that's what's important to be mindful of. Really know what you're trying to solve and what are the tools out there that are available for you. Of course, sometimes you just inherit projects that are already, during their life cycle, and you just got to learn whatever they're written in. That's happened to us, and I'm sure it'll happen to us again in the future, and anyone listening. So if you do have the option though of planning ahead, I think it's important to know what languages are out there and what are they best suited for, I would say. I think that's it. I don't know if you want to add anything, Kovit, or if Cole, you guys want to add anything else? I think that's it.
I think we are over time. We just want to see if they have any questions. Okay. Thank you, everyone. We'll share the link to the code, and you can always email us when you reach us out if you have any other questions. Thank you.
Thank you.
Thank you.